In this lesson, we're going to add and subtract rational expressions. So we're going to start by adding and subtracting expressions that have like denominators. So to do this, you add or subtract the numerators, keep the common denominator, and then make sure we simplify if necessary. So let's look at a problem number 1. Notice that the denominators are 3x and 3x. Because these are the same exact denominator, we are going to keep 3x in the bottom. Then we are going to take these top numbers, 5 plus 7, and add them together. So when we simplify this down, we're going to get 12 over 3x. Notice I did not add 3x and 3x. I only add the numerators. So now we have to simplify, if possible. And notice that 12 and 3 can both be divided by 3. 12 divided by 3 and 3 divided by 3, which would give us 4 over x. And that is simplified as far as we can go. Now we are going to state any restrictions on the domain, meaning what can x not be. So when we're determining this, we're determining it back from the original expressions. So if we think back, we say, okay, 3x cannot equal 0, so that means x cannot equal 0. So our restriction is going to be x cannot equal 0. And that right there would be our final answer for that one. All right, let's try number 2. So number 2, again, we're looking at the denominators, x plus 2 and x plus 2. Those are exactly the same. So we're going to keep that x plus 2 on the bottom. We don't add them, we don't subtract them, we don't change them. We just keep x plus 2. And then we're going to take and we're going to say 2x. Now this time we have a minus, so we're going to do minus, and we have to put x plus 1 in parentheses because we have to take and distribute that negative to both pieces. So this is really going to be 2x minus x minus 1. And it's still going to stay over that x plus 2. So now it's just a matter of simplifying it down. So 2x minus x, those are like terms, so that's 1x minus 1 over x plus 2. Now remember, x minus 1 and x plus 2, they're grouped together in pairs because they have pluses and minuses. We cannot say that this is negative 1/2. That is wrong, wrong, wrong. You can't cancel out those x's. You have to keep it as x minus 1 and x plus 2. And because those are not like factors, we cannot simplify that anymore. But we do need to put down our restrictions. So again, our restrictions come from the denominator. So what value of x would make that 0? So if x plus 2 cannot equal 0, if you solve that, you would get x would equal negative 2. So we cannot let x equal negative 2, otherwise we would have a 0 in the denominator. And you can see that negative 2 plus 2 is 0. All right, number 3. Again, looking at the denominators, 2x minus 18, 2x minus 18. So they are the same. So we're going to write down 2x minus 18. Our numerators, we're going to have x squared minus 81. Now notice this time I didn't put 81 in parentheses, and that's because there's only one term. If there's multiple terms, you must put the parentheses, but you could put them if you want to get into that habit. That's not a bad habit to get into. Now, you might think we're done, but notice that the top and the bottom would both factor, which means we're going to have to simplify this down just a little more. So the numerator is a difference of squares, which would be x and x, plus and minus, and then 81 would be 9 times 9. In the denominator, we would have a 2 that is a greatest common factor, giving us x minus 9. And this is where we have to be sure that it doesn't simplify more, because these factors here, this x minus 9 and this x minus 9, would cancel, see ya, and we are left with x plus 9 over 2. And you can put the parentheses or leave it without. And then again, we have to give our restriction. Now, when we're looking at our restriction, you might think, oh, there isn't one. 2 will never equal 0, and that's true. But you have to go back to the original denominator. X minus 9 was a factor. So that means we cannot let x be positive 9, because 9 minus 9 would equal 0, and we cannot let those be equal. Okay, if they don't have the same exact restrictions, they're not equivalent expressions. Okay, so those are when there's like terms. Always factor it down completely. Okay, even if this expression here had not simplified, I would have still left it in factored form. Okay, so always factor as far as you can. You don't have to multiply it back out. All right, that is adding and subtracting with like denominators. Now, before we try to work with unlike denominators, we're going to talk about something called finding the least common multiple. Now, you probably talked about this in maybe 5th grade, middle school, kind of somewhere in there. So back then you would have done something like maybe 2 and 6. You would have said find the least common multiple. So you'd start counting 2, 4, 6, 8, 10, and so on. 6, 12, 18, and so on. You would have said, oh, look, 6 is the least common multiple. Now they have other common multiples. 12 is a common multiple, 18 would be 24, but this would be the least. So we're going to do the same kind of concept, but we are going to do it with polynomials. Okay, so we're looking at the polynomials 3x and 3 times x minus 2. So the first thing I'm going to do is I'm going to say, okay, 3x is really 3 times x. Okay, that's what it really means. Maybe I'll make it equal to 3 times x. So then we're going to take a look at 3 times x minus 2. So 3 times x minus 2 is simply 3 times x minus 2. Okay, those are completely factored, just like in step 1. So that was our first step, factor them completely into prime numbers. So 3 is already prime, 3 is already prime. Now we're going to start by looking for the things they have in common. So when I look at these problems, I noticed right off the bat we have a 3 in common. So part of my least common multiple, I'm going to need a 3. They have a 3 in common. Then I'm going to look at the things that they don't have in common. So in this case, this one has an x. Well, I'm going to write that x down. So I'm going to add that x next to 3x, because in order for them to be multiplied, I would need 3x. Then I look here again. Okay, this guy's got an x minus 2. I need to add that to my least common multiple. So x minus 2. So my least common multiple would be 3x times x minus 2. What that means is I could multiply this expression, this 3x, right here. I could multiply it by x minus 2 to make it the same as my second expression. Now my second expression, I would have to multiply by x. So notice if by multiplying by these new expressions, this least common multiple, I can get the same exact expression. Okay, and this is going to be important when we start trying to find common denominators. We need to be able to create the same expression by multiplying by the same value. Okay, so our least common multiple is 3x times x minus 2. All right, so if you're a little confused, don't worry. We're going to work a couple more. It takes practice. So number 2, this time we have 24x squared. So we're going to start by breaking 24x squared down into its prime factors. So maybe we have 2 and 12, and we have 2 and 6, and we have 2 and 3. So what we have here is we have 2 cubed times 3 times x squared. That's 24x squared. Now, 8x squared, and I'm actually going to erase my little factor tree, guys, so that I have a little more room to work here. So now I have 8x squared minus 16x. So the first thing we're going to do is we're going to factor this out as far as we can. So they have an 8 and an x in common. That's the greatest common factor. And then that would leave us with x. 8x times x is 8x squared. 8x times negative 2 is negative 16x. So if we factor 8 down, that'd be 2 times 4 and 2 times 2. So we'd have 2 cubed times x to the first times x minus 2. So just like before, in order to find our least common multiple, we're going to start by looking at what they have in common. So they have a 2 cubed in common. So we're going to start by writing 2 cubed down. Now, they also have 1x in common, because I could have rewritten this x squared as x times x. So they also have a single x in common. So I'm going to write an x down. Okay, now that we have the common stuff down, we're going to kind of ignore it, and we're just going to look at the stuff that they don't have in common. So this first factor has a 3x, so we have to multiply by 3x. We're going to add in that piece that we didn't have in the first part. So we already had 2 cubed and x, now we need 3x. Over here on this second polynomial, we need x minus 2. Okay, that's the only one that's not in common. So x minus 2 needs to be written down next to this, so x minus 2, because that's the only factor that's not accounted for. And now our last step is going to just simplify this down. So 2 cubed is 8, so I have 8x times 3x times x minus 2, which means my least common multiple, 8 times 3, we can multiply that, is 24. X times x is x squared, and then x minus 2. And notice I'm not multiplying 24x squared times x minus 2. That's because I want this to keep this factored. I do multiply the monomials, the coefficients together, simply because it's easier to work with. So always multiply the single terms, but leave any binomials or trinomials alone. All right, last one, number 3. Find the least common multiple between 4x squared minus 16 and 6x squared minus 24x plus 24. All right, so let's start with 4x squared minus 16. So that has a greatest common factor of 4, leaving us with x squared minus 4, which would factor down into 4 times x plus 2 and x minus 2. That's a difference of squares, which would factor down into 2 times 2 times x plus 2 times x minus 2. So those are the prime factors. So now we're going to look at the second expression. I'm going to do it in a different color, maybe keep our eyes a little bit easier to see. So 6x squared minus 24x plus 24 again. Now, this has a greatest common factor of 6. So we're going to take out that 6 first. So x squared minus 4x plus 4. This is going to factor a little more, x minus 2 and x minus 2, and even a little bit more because 6 is really 2 times 3. And then we have x minus 2 times x minus 2. So now we have to find our least common multiple. So we're going to start by figuring out what they have in common. So it looks like we have a 2 in common. We also have an x minus 2 in common. Okay, so we're going to start by writing those two pieces down. So we have 2 times x minus 2. Then we're going to find what they don't have in common. So on this first polynomial, I need a 2 and I need an x plus 2. So I'm going to add in a 2, so times 2 times x plus 2. And then on my last one, this guy needs a 3 and an x, another x minus 2. Notice they only had one x minus, so we need 2 of those x minus 2s. So we're going to add in times 3 times x minus 2. Now we're going to simplify it down just a little bit. So we're going to multiply these 2 times 2 times 3 together. So our least common multiple so far is 2 times 2 is 4 times 3 is 12. And then notice we have 2x minus 2. So we can shorthand this by saying x minus 2 squared. And then we need 1x plus 2. And the good news is the order does not matter about your binomials, your terms, your factors. The only thing that needs to be in the right place is we typically put the constant in the front. So that 12 should always be in the front, any monomials. So 12, 24x squared, back up here 3x. Anytime we have a monomial, that stays at the front of the greatest common factor, or sorry, least common multiple. Okay, so that kind of gets us an introduction to adding and subtracting. We have to find common denominators. Okay, so being able to find the least common multiple.